Hi everyone, and welcome to lesson 4.2. Today we're going to be talking about the standard form of a quadratic function. Now, first of all, any function that can be written in the form f of x equals ax squared plus bx plus c, where a is not equal to 0, is said to be in standard form. You can find information about the quadratic function from the coefficients a, b, and c. So what we're going to do today is we're going to look at the equations of quadratic functions, and we are going to use the information given in the equation to figure out what our graph looks like. So we can find a lot about our graph just by simply looking at the equation of a quadratic function. And I'm going to teach you how to do that today. So first of all, let's look at some properties of quadratics in standard form. So the first thing I want you to notice is that the graph of a quadratic function is a parabola. Okay, and you might remember this back from Algebra 1, but if you have a parabola, then you're looking at an equation that has x squared in it. So a quadratic equation is going to be represented on a graph using a parabola. Now, a couple of things to note about the equation of a parabola. If a, or the leading coefficient, is greater than 0, the parabola is going to open upward. Okay, so in other words, if this number right out front, the first leading coefficient, if that number is positive, then that means your graph is going to be opening upward, just like so, okay? Now, on the other hand, if a is less than 0, so if that leading coefficient of the function is negative, that means that your parabola is going to open downward. Now, a couple more things to note about the equation of a parabola, or a quadratic function. The axis of symmetry is the line x equals negative b over 2a. Okay, now that might look familiar. That's actually part of the quadratic formula, but the x-coordinate of the vertex and the axis of symmetry of a parabola is going to be represented by the formula x equals negative b over 2a. Now, just like I said before, the x-coordinate of the vertex can be found by finding x equals opposite b over 2a. And what this tells you is basically wherever the vertex is, there's a straight line that goes down through the vertex. That is your axis of symmetry. And you can also use that equation to find the x-coordinate of the vertex. Now, to find the y-coordinate of the vertex, all you're going to have to do is you're going to have to plug in whatever you found for x. So f of negative b over 2a, and that's going to give you your y value, okay? So first things first, you got to use the formula negative b over 2a to find your x-coordinate, and then once you find your x-coordinate, you can simply plug in your x-coordinate to the function and figure out what your y value of the vertex is going to be. And then last but not least, the y-intercept is simply going to be represented by 0, comma c, okay? So whatever that c value is, so if we take a look at that top formula here, that c value at the end, that is going to represent your y-intercept. So we're going to write that down as 0, comma, whatever that c value is. Let's go ahead and move down to the first example. So we're first going to find the features of a quadratic in our notes today. So example number 1 says, use a calculator to find the features of the quadratic by looking at the table. We have y equals negative 3x squared minus 6x plus 8. The first thing that I want to do is I'm going to fill in some values using my table over here. So using a calculator, I obviously can't show you what it's going to look like by plugging in the values into your calculator, but quickly just use your calculator to plug in some values into this table. I'm going to go ahead and start at negative 4. So that's the first x value I'm going to plug in. So if I plug in negative 4, I have negative 3 times negative 4 squared minus 6 times negative 4 plus 8. And that is going to give me a value of negative 16. Then let's plug in negative 3. So if I plug in negative 3, I have negative 3 times negative 3 squared minus 6 times negative 3 plus 8. And that's going to give me negative 1. Then if I plug in negative 2, I'm going to keep going down that number line. Negative 3 times negative 2 squared minus 6 times negative 2 plus 8, that's going to give me positive 8. Then if I plug in negative 1, I'm going to get negative 3 times negative 1 squared minus 6 times negative 1 plus 8, and that is equal to 11. Now I'm going to plug in 0. Now when I plug in 0, I notice that my value is simply going to be negative 3 times 0 squared minus 6 times 0, all of that just turns into 0, and then I get 8 for my y value. So if I notice here, I have 8 right up top here for a y value, and I have 8 again right here. Interesting. So go ahead and keep looking at the pattern that we're going to notice. So then if we plug in, say, positive 1, we're going to have negative 3 times 1 squared minus 6 times 1 plus 8. And that gives me negative 1. Now I'm noticing a pattern. I am noticing that this point, once I get to this point, all of my values start to repeat. So I get 8 and negative 1. And if we notice on the other side of this center point right here, I have 8 and negative 1. So using our logic and just our recognition of the pattern here, we can assume that if we were to plug in 2, that we would get negative 16. And I'm just going to plug it in just to make sure. But if we have negative 3 times 2 squared minus 6 times 2 plus 8, we notice that we do, in fact, get negative 16. So this is telling you that this point right here, negative 1 comma 11, is kind of a big deal. So I'm going to have you guys highlight that. Negative 1 comma 11 is kind of a big deal. That is the point on our graph that represents the vertex, okay? Because if we remember what a parabola looks like, a parabola is a point or a graph. It's a graph that looks something like this. So I know that this right here is negative. So that means that I'm going to have a downward facing parabola. So what this is telling me right here is that my vertex is right here in the center. And what's happening is the y values are going up, 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 and up. Once we get to that point, they start going down, 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 and down. And we have an axis of symmetry straight down the center of that vertex. So what that's telling us is this point right here represents the vertex of that graph because that's where all of the changes are happening, okay? That's where the top of the graph hits, and then we start going back down and hitting all of those same y values, okay? So the vertex of this graph is going to be negative 1, comma 11, okay? Now, once we know what the vertex is, it's very easy to find the axis of symmetry because the axis of symmetry is literally just x equals whatever the x coordinate is of the vertex, okay? Because that's where that imaginary reflection line is going to be going through. So we have x equals negative 1. And again, we get that from looking at the x coordinate of the vertex. That is what my axis of symmetry is going to be. Now we're going to look and see if this is a maximum or a minimum. Like I said before, this graph faces downward, okay, because that a value is negative. And if the a value is negative, that means that we're looking at a graph that faces downward. So on this graph, we have a maximum point right up here at the vertex, okay? Or in other words, I want you to think of this as like a mountain. This is the top of a mountain, okay? This vertex is up there. The graph is pointing down. So that means the vertex is going to be the very top of the graph. So I am looking at a maximum here and not a minimum. Now, if your graph were a regular looking parabola, one that faced upward like this, then you would have a minimum point because the vertex would be at the very bottom. But since we're looking at a vertex and a parabola that faces down, we're looking at a maximum value instead of a minimum value. And that maximum value is simply going to be the y value at the top of the graph. So the y value at the top of the graph is just going to be the y value of the vertex. So I am having a maximum at y equals 11. That is the very top of my graph, the very top of my range that's happening here, okay? Now I want to think about this as well. So what is my range going to be for this function? Well, once again, if I know that the top of my graph is going to be right up here at the vertex, negative 1, comma 11, my range is going to be all of the y values that fall below that vertex because that graph is going forever and ever and ever in the downward direction. So that means that the range is going to be represented by all of the values beneath the vertex. So the way I'm going to represent that is I have to go from negative infinity, all right, because that's all the values going down to negative infinity. But my range is going to stop right up top there at 11, and I am including 11 because the vertex is negative 1, comma 11. So I am including 11. That is a solid dot on my graph, but my range is going to be all the way from negative infinity up to that vertex at positive 11. And that is how you use a calculator and you use a table of values to figure out the features of a parabola. Let's go ahead and move to the next page. So now we are going to look at graphing a function of f of x equals ax squared plus bx plus c. So here's the procedure we're going to use today to graph a parabola in standard form. I'm just going to put a little box around this just so you can see, hey, this is kind of a big deal. So the first step, we are going to identify a, b, and c inside of our function, okay? So we're going to look at our equation, and we're going to compare it to this parent function up here, and we're going to find what a, b, and c are. The second thing we're going to do is we're going to determine the shape of the graph, okay? We're going to determine whether it faces upward or downward. We have to figure that out first. The third thing we're going to do is we're going to find the axis of symmetry, and then we're going to sketch the graph. Then we're going to find the vertex, okay? The vertex, we have to find the x-coordinate using x equals opposite b over 2a. And then we have to find the y-coordinate by plugging in whatever we got for x. So f of opposite b over 2a, okay? Then we're going to plot the y-intercept. Remember, the y-intercept is represented by 0, c. Then we're going to find a reflected point, and we are finally going to sketch the curve. So let's go ahead and move down to example number 2. We have y equals x squared minus 4x plus 1. First things first, I want to figure out what a, b, and c are. A is always going to be that first leading coefficient. B is always going to be the middle number, and C is always going to be the last number, okay, the constant at the very end. Now, A, since I don't have a number in front of my x squared, A is simply going to equal 1. B is going to equal that coefficient in front of the x, the middle coefficient, and that is equal to negative 4. And then C is equal to positive 1. So now that I figured out what a, b, and c are, I can move on to step number 2. Now, step number 2, is this graph going to face upward or downward? Well, since my a value is positive, that tells me that my graph is going to be facing upward. This is a regular looking parabola because a is a positive number, so my graph is going to face up. And I'm just going to draw that off to the side here, just so I remember my graph is facing upward. The third step is to find the axis of symmetry. Now, if you remember from the previous page, we said that the axis of symmetry, I'm going to call that AOS, that is going to be x equals opposite b over 2a. So let's go ahead and figure out what this is. So if I plug in opposite b over 2a, I get x equals opposite b. Opposite b is just going to be the opposite sign of b. So since b is negative 4, negative b is just going to be positive 4 over 2a, which is 2 times 1, okay? So this is going to turn into 4 over 2, which 4 divided by 2 is just 2. So we have x equals 2 is our axis of symmetry. So on my graph, I'm just going to go ahead and put my axis of symmetry down at x equals 2. This is going to be a dotted line straight down through the x-coordinate right there at 2. Okay. Now I have to find my vertex. So once again, my vertex is going to have an x-coordinate that is represented by this axis of symmetry. So if I'm finding my vertex, first of all, I'm going to write that in the same color. Sorry. It just drives me a little crazy when it's not the same color consistency. Okay, so the vertex, I already know that 2 is my x-coordinate because I find my vertex by doing opposite b over 2a for x. Then I have to plug in my x value to the function to figure out what my y value is going to be. So I know that y equals x squared minus 4x plus 1. So I'm going to plug in 2 for x. So I have 2 squared minus 4 times 2 plus 1. I know that 2 squared is equal to 4, so I have 4. And then negative 4 times 2 is going to give me negative 8. Plus 1, and I know that 4 minus 8 is going to give me negative 4, and negative 4 plus 1 is going to give me negative 3, okay? So my y-coordinate is going to be negative 3, so that tells me that I have a vertex at 2, negative 3. Okay, so I'm going to put this on my graph at 2, negative 3, right about there. And now I know that my graph is going to face upward, and I know that I don't have any funky like stretches or shrinks or anything like that. So I can just go ahead and start graphing this. But in order to do so, I might want to put my y-intercept on the graph first and then use reflection to go ahead and get some points on my graph. So next things next, I know that my y-intercept is going to be 0, c. And since my C value is 1, that means that my y-intercept is simply going to be 0, 1. So at 0, 1, I'm going to put a point. And then I can reflect the axis of symmetry. So since I'm going to the left 2 to get to that point, I'm going to go to the right 2 on the other side, and I'm going to plot that point right here. Okay? All right, let's go ahead and put one more point on our graph just for grins so that we can make sure we have at least somewhat of an idea of where this is going. So I'm also just going to put one more point. So one more point. I'm going to put this down here. Let me make this neat by bubbling that in. And so one more point. I'm going to plug in, let's do one that's right about here. So let's do one that's at -1 and +5. Okay, let's go ahead and do one there. So if I plug in -1 for x, I'm going to say x equals -1. If I plug this into my function, I'm going to get y equals -1 squared minus 4 times -1 plus 1. -1 squared is just +1. -4 times -1 is going to be +4. And +1. 1 plus 4 is 5. 5 plus 1 is 6. So what this is telling me is I have another point at -1, 6. Okay? So I'm going to go ahead and plot this on my graph as well. So at -1, 6, I'm going to go up 1, 2, 3, 4, 5, 6. And then I can reflect that point to the other side as well. So if I'm going to the left 3, I can go to the right 3 and plot my point. And now I can connect my dots with a smooth curve, because I know that a parabola is going to have a smooth curve. Okay, so try to make this as nice as possible. And that is what my graph is going to look like for y equals x squared minus 4x plus 1. So first things first, we are going to just figure out what our a, b, and c value is. Then we're going to determine the shape of the graph, find the axis of symmetry, then find the vertex. After you find the vertex, put your y-intercept down and reflect the point. And then just to make your graph even neater, I would like you to plot one additional point. You can plot whatever point you want. I would just do the one that's right next to the points that you've already plotted. But you are welcome to plot one more point just to kind of get an idea of where your graph is going. Okay? All right, let's go down to example number 3. We have y equals -2x squared plus 2x minus 5. First things first, I would like to see what my a, b, and c values are. So let's take a look at this. A value is right here. Okay, that is -2. So I'm going to say a equals -2. B value is right here. That's going to be +2. And C value is right here. C is equal to -5. Okay. So now I figured out what my A, B, and C values are. I need to figure out what the shape of my graph is going to be. So is this going up or down? Well, since my leading coefficient, or my A value, is negative, that means that my graph is going to be facing downward, because if it's negative, it faces down, all right? Now that I figured that out, I'm going to go ahead and figure out what my axis of symmetry is. So my axis of symmetry, I actually have a spot for that right here, but I'm going to write this down anyways, so I can show you my math. But my axis of symmetry is going to be x equals -b over 2a. So if I plug in -b over 2a, -b is going to give me -2 over 2a. 2a is going to be 2 times -2. And that's equal to -2 over 2 times -2. That's going to be -2 over -4. And then I know that these are going to cancel. 2 over 4, I can simplify that fraction. If I pull a 2 out of 2, I just get 1. If I pull a 2 out of 4, I just get 2. So I have x equals 1 over 2. That is going to be my axis of symmetry. So x equals 1 over 2. All right, let me go ahead and put that on my graph. So at 1 over 2, on the x-axis, I'm going to put a little dotted line here just to show you, hey, this is my axis of symmetry. Okay, so now I have to figure out what my vertex is. And obviously I know that the x-coordinate of my vertex is literally just going to be whatever that axis of symmetry is. So I'm going to put for my x-coordinate 1/2. And then I have to plug 1/2 in to figure out what my y value of my vertex is going to be. Okay, so if I'm looking at my vertex, I already know that x is equal to 1/2. So if I plug in 1/2, I'm going to have -2 times 1/2 squared plus 2 times 1/2 minus 5, okay? So I know that negative 2 times 1/2 squared, that's going to be negative 2 times 1/4 plus 2 times 1/2 is just going to give me 1 minus 5. Then if I have negative 2 times 1/4, that is going to give me negative 1/2 plus 1 minus 5. Negative 1/2 plus 1 is just going to be positive 1/2 minus 5. If I want like denominators, I'm going to have to multiply the top and the bottom by 2. That's going to give me 1/2 minus 10 halves, which is equal to negative 9 halves. All right, so all of that math just to show me that my y coordinate here is going to be negative 9 halves, or in other words, negative 4.5. Okay, so let's go ahead and plug that in onto my graph. So I have negative 1/2, or excuse me, positive 1/2, negative 9 halves. So at 1/2, I'm going to go down 1, 2, 3, 4, 4.5. And that right there is going to be my vertex. Once again, this graph is facing downward, so I'm going to be going down. Let me figure out what my y-intercept is. So if I plug in 0 to figure out what my y-intercept is going to be, I know that my y-intercept is always just going to be 0, comma, whatever the c value is. So I have 0, comma, negative 5 for my y-intercept. So at 0, negative 5, I'm going to put a point right here. Then I can reflect that. So since I'm going over 1/2 and plotting a point, I can go to the right 1/2 and plot a point. So the right 1/2, I'm going to plot a point here. Let's go ahead and do one more point just so that we can see kind of what's happening here with the graph. And if I want to put that reflected point down in my graph, that's going to be 1, negative 5. So I can put 1, negative 5 down here. And let's go ahead and put one more point. And so for this last point, what I'm going to plug in is, I'm just going to go ahead and plug in, let's do negative 1. If I plug in negative 1, I'm going to kind of see what's happening here. And then I can reflect it to the other side of the graph, which will be right about here. Okay, so I want to reflect some things. So my one more point, I'm going to plug in x equals negative 1. I want to kind of see what's happening when x equals negative 1. You can plug in really any point just to kind of get an idea of where your graph is going. So if I plug in negative 1, I have negative 2 times negative 1 squared plus 2 times negative 1 minus 5. So negative 2 times negative 1 squared, that's going to be negative 2 times 1 minus 2 minus 5. That is equal to negative 2 times 1 is negative 2 minus 2 minus 5. Negative 2 minus 2 is negative 4. Negative 4 minus 5 is negative 9. So I know that if I plug this in, this is y equals, if I plug x in, negative 1, and I get out a negative 9, I have a coordinate at negative 1, comma, negative 9. So let's go ahead and put that on my graph. So at negative 1, comma, negative 9, right about here, I have a point. And then I can reflect that. So since I'm going over 1, 2, 2.5 to the left, now I can go 1, 2, 2.5 to the right. So I'm going to have a point right about here. Oh, that was 1.5, excuse me. 1.5 to the left, and then I go 1.5 to the right. So since I've reflected that point, I can now connect my dots, and my graph is going to look something like this. All right. And that is how you graph a parabola. All right, let's move on to the next page. So next page, we are going to find vertex form given a quadratic equation. So find the vertex form for f of x equals 2x squared minus 8x minus 3. All right, well, let's go ahead and see what we're doing with vertex form. So vertex form, keep in mind, is represented by y equals a times x minus h squared plus k. So the goal is we are taking a quadratic equation that's in standard form and we're putting it in vertex form, okay? So again, the goal is to get in y equals a times x minus h squared plus k form, okay? So first things first, I'm gonna follow a few different steps in order to get this done. So the first thing I want you to look at, I want you to look at what your a value is because we can easily find what our a value is up here, and then we can plug in our a value down here. So I know that a is equal to positive 2 because, again, the leading coefficient here is positive 2, so a is equal to positive 2. That's the first thing we're going to do. Then the second thing we're going to do is we're going to find the vertex given the standard form of the equation. So the vertex is represented by HK. Oops. Vertex. What am I even talking about? Vertex, and that's going to be H, comma, K. And in order to find this, I know that I have to do X equals opposite B over 2A. So the first things first, I'm going to say X equals negative B over 2A. I know that negative B, well, B right here is negative 8. So opposite of negative 8 is going to be positive 8 over 2A, and 2A is going to be 2 times 2. So I have 8 divided by 2 times 2. Well, I know that 2 times 2 is 4, and 8 divided by 4 is going to give me 2. Okay, so that's the X coordinate. Then if I plug in this 2 into my function to get out a Y value, if I plug in 2, I'm going to have Y equals 2 times 2 squared minus 8 times 2 minus 3. Well, 2 times 2 squared, that's going to be 2 times 4 minus 8 times 2, which is minus 16, minus 3. 2 times 4 is 8. 8 minus 16 is going to give me negative 8. And negative 8 minus 3 is going to give me negative 11. Let me simplify that a little bit. So I have 8 minus 16 minus 3, and that is equal to negative 11. Okay, so my vertex here is going to be represented by 2, comma, negative 11. And I know, again, that this is H, comma, K. Okay. And the last step is we are going to put this in vertex form by plugging in all the stuff that I have been given. So I know that A is equal to 2, so I'm going to say vertex form. And I know that A equals 2, so the first thing I'm going to put is, let me write this in a different color. I'm going to say, let's do that here. Okay, Y equals A, which is 2, times X minus H, so X minus H is going to be X minus 2 squared plus K, okay? K is negative 11, so I'm going to do negative 11. So my vertex form is going to be Y equals 2 times X minus 2 squared minus 11. All right, let's go ahead and do this for example number 5 as well. So first things first, once again, I am going to find my A value. So my A value is represented by negative 1, so A equals negative 1. Next thing I'm going to do is I'm going to find my vertex. I know that my vertex can be found by saying X equals opposite B over 2A. So opposite B over 2A is going to be negative 4 over 2 times negative 1. Negative 4 divided by 2 times negative 1 is negative 4 divided by negative 2, which is going to give me positive 2. If I plug that in, I have negative 2, Y equals negative 2 squared plus 4 times 2 minus 5. Okay, that turns into negative 2 squared is negative 4 plus 4 times 2 is 8 minus 5. Negative 4 plus 8 is going to be positive 4. Positive 4 minus 5 equals negative 1. So my vertex is going to be 2, comma, negative 1. Once again, that is going to be represented by H, comma, K. Okay, last but not least, we're going to put this in vertex form. So third step, we're going to put this in vertex form. And vertex form, as we know, is going to be Y equals A times X minus H squared plus K. So I'm going to say Y equals A. I know that A is negative 1 from above. X minus H is going to be X minus 2 squared. Plus K is going to be minus 1. So my answer is Y equals negative X minus 2 squared minus 1. All right, so now we're going to look at example number 6, interpreting a quadratic. We have the following question. A model for the performance of a stock is P equals negative 3D squared plus 50D, where D represents the days of trading and P is the price per share. What is the maximum price per share of the stock? Okay, the first thing I want us to look at is we're going to look at this function right here. P equals negative 3D squared plus 50D. The next thing I'm going to look at is that we are trying to find the maximum price per share of the stock. So if we're looking at the maximum price, right, what I want you to recognize here is that this graph, because of its A value, again, we're looking at this A value right here, because of its A value, it is facing downward. Okay, we have a negative A value, which means the graph is facing down. So if we're looking for the maximum, that is going to be the vertex right up here. But not only is it going to be the vertex, but it's specifically going to be the Y value of the vertex. Okay, the highest point on the graph is the Y value of that vertex. So what I am looking for to solve this problem, I am going to find the y value of the vertex. Okay, and that's going to give me the very top of this graph. In this case, we changed up our variables a little bit. D represents the days in trading, and P is the price per share. So essentially what we're saying here is that P is our y value in this case, and D is our x value in this case, okay? So let's go ahead and find the vertex first of all, using this equation up here. So obviously I only have A and B. I don't have a C value, because this is just going to be plus 0 at the end. So my C value is just unknown. It's just 0, right? So we don't even have to worry about it. So in order to find the x coordinate of our vertex, we're going to say that, in this case, we're talking about D. So we're going to say that D is equal to opposite B over 2A, which is negative 50 over 2 times negative 3. Now, if I simplify this a little bit, this is going to be equal to negative 50 divided by negative 6. I know that a negative divided by a negative is a positive, so I can cancel those out. And then I also know that I can reduce this fraction a little bit. So if I pull something out of 50, I can pull a 2, and that gives me 25. And then I can pull a 2 out of 6, and that's going to give me 3. So I have 25 thirds as my x coordinate, or in this case, my d coordinate. So this is going to be 25 thirds. And then in order to find the y value of the vertex, I have to plug this value in to the function to get whatever the y value is. So I'm going to plug this in, and I am going to say P of 25 thirds is equal to, if I plug this in, I get negative 3 times 25 thirds squared plus 50 times 25 thirds. Okay, so if I plug this in, I'm going to use my calculator just because this is a really ugly thing, and it's going to turn into a decimal anyways, so just use your calculator for this one. Be very careful when you're plugging in fractions, however. Very easy to mess things up. And what I'm getting is that my P value, or my price per share, is going to be approximately $208.33, okay? So what this is saying is that the max price per share, okay, so that top y value, right? So the highest the price can go, the max price per share is going to be $208.33. Okay, and that is going to be the answer to this problem. $208.33 is the max price per share. Moving on to the last page. So the last page is just an interpretation of a quadratic graph yet again. So we're going to say the New River Gorge Bridge in West Virginia is the world's largest steel single arc bridge. You can model the arc using the function y equals, ooh, that ugly decimal, where x and y are measured in feet. Approximately how high above the river is the bridge? How long is the bridge? So we are looking for, first of all, how high off the river the bridge is, okay? I know that the height of the arc is going to be represented right here. But then also the actual arc itself starts above the river. So we're also going to have to add this value down here just to get the total distance from the river to the height of the arc. And then also we're trying to figure out how long the bridge is. So we're looking from left to right. Okay? All right, so let's go ahead and start. First things first, I want to figure out what this top point is going to be, or in other words, what my y value is going to be up here. Because if I can find my y value up here, it's going to be pretty easy to figure out what the height of the actual bridge is going to be. So the first thing I'm going to do is I'm going to say x equals negative b over 2a. I have to find the y value, but before I can find the y value, I got to figure out what the x value of the vertex is going to be. So I'm going to figure this out. X equals negative b, that's going to be negative 0.847 over 2a, which is going to be 2 times negative 0.000498. Oh my goodness. So if I plug this into my calculator, I'm going to get negative 0.847 divided by 2 times negative 0.000498. That is going to give me, oh my goodness, this interesting number, which means x is approximately going to be, I'm going to round this to the nearest whole number, 850 feet. Okay, so it's about 850 feet. So if I were to plug this back into the function, now I'm going to figure out what my y value is. So I'm going to say f of 850, which in this case is going to equal So if I plug in 850 to the function above, this is going to be negative 0.000498 times 850 squared plus 0.847 times 850. Lots of 8s happening here, lots and lots of 8s. So now, this is going to simplify too if I plug this into my calculator. Negative 0.000498 times 850 squared plus 0.847 times 850. Oh my goodness, this comes out to about 360. So I'm going to say y is approximately 360. Okay, and once again, we are talking about feet. All right. Wow, that was really something. Okay, so here's the deal. If I am figuring out that this right here, 360 feet, if that is going to be the height of the arc, right? So what I'm saying, I'm going to try to write this in a light color here. But what I'm saying here is that the height of the arc is 360 feet. So we're looking at that kind of neon green thing that I just wrote down. But I don't just want to find the height of the arc. I want to find the height of the bridge from the river. So I want to find this whole distance right here, but I only know that 360 feet represents this distance right here. So in order to find the total distance, I am simply going to take 360 and I'm going to add it to this height that's already given right here, which is 516 feet. So in order to find the river to the bridge height, that is going to be represented by, like I said, 360, which is the y value that I found, plus 516. And 360 plus 516, that's going to give me 876. So I know that the height from the river is going to be 876 feet, okay? Now I need to figure out what the length of the bridge is, okay? So we're figuring out, all right, well, what's the length of the bridge? And that is represented up here. What is this length up here, okay? So I'm gonna figure out how to do this. So length of bridge. Now what we know about this bridge so far is we know that the x coordinate of our vertex, so this top point right up here, we know the x coordinate of that vertex is going to be 850 feet. So what that is saying is that 850 feet pass by until we get to that vertex, right? 850 whole feet are passing by until we get to the middle of that length of the arc, okay? The middle of the length is 850 feet. So in order to find the second half of the length, we are literally just going to take 850 feet again, and we're going to add these two 850s together, and that's going to give you the total length of the arc. Because again, the x value here is 850, so that means from 0 to 850, that is going to be the first half of my graph, and then obviously the second half is going to be the same distance. So all I'm doing here is I am taking 850 plus 850, and that is going to give me 1,700 feet, right? So that is how you deal with a word problem that deals with a quadratic equation. All right, you guys, that is lesson number 4.2. Please make sure you do your assignment, and I will see you back here next time.